Hi, you may be interested in this video if you own a groovebox like MC-101 or MC-707 or something similar and you wish it had a sidechain compression feature, but it doesn't. In this video, I'd like to share with you my workaround for that problem. I made a MIDI gadget that can emulate the sidechain compression effect. The MIDI Sidechain Gadget uses an inexpensive off-the-shelf hardware board and a USB adapter cable. It works as a USB host, so it can be connected directly to MC-101 or MC-707. This way, it doesn't unnecessarily occupy the available MIDI DIN ports. The hardware doesn't require soldering or any other custom modules. I also made a version that uses even less expensive board, but at the cost of a limited user interface. Still, even the less expensive version can be optionally upgraded using commonly available modules. To use the gadget, the MC Groovebox has to have the USB driver set to generic. In my case, to avoid the USB noise, it was enough to connect the gadget to a separate power adapter whenever the computer connection was not necessary. This way, I avoided the ground loop that probably causes the USB noise. In my case, it worked quite nicely. Initially, I wanted to make a device that can apply a sidechain-like effect to MC-101 or MC-707, but it appears it may work with other USB MIDI devices as well. I successfully tried running it with a USB MIDI converter. Then I connected an analog synthesizer to that setup and it worked too. Anyway, I'm showing you the tests later in this video. But, I cannot guarantee that it will work with anything. As the main hardware platform, I've chosen an old but still supported and relatively inexpensive development board, the STM32F4 Discovery from ST. Or let's just call it the Disk 1. The Disk 1 board has a couple of flaws like the unreliable touchscreen controller and poor viewing angles on the LCD display. But it uses a very reliable and popular microcontroller with flexibly configurable software drivers. What's important, the software for one STM32 microcontroller can be ported to other or newer STM32 microcontrollers. For me, it was especially important with the USB software stack. Those were the main reasons why I've chosen STM32 microcontrollers for this project. I'm totally aware that the board is rather old, and I'm aware that it can become unavailable in a couple of years after the time I finish this video. So I developed an alternative version of the software which can run on a generic Nucleo-144 board with a similar microcontroller, also from ST. The Nucleo-144 boards don't have any LCD display or a touchscreen, but they can be used to implement the MIDI Sidechain Gadget too. Then the user interface is even more minimalistic unless you add a couple of extra components. Without the user interface components, I am still able to configure the Sidechain Gadget using a computer. And after disconnecting it from the computer, I can still control the main parameters over MIDI. I can also change the prepared presets and save the modifications using the onboard blue push button. The software is rather a draft. It's very fresh and I didn't test it extensively. I developed it in C language. I share the software projects with the source code on my GitHub and the links are in the description. I used the following tools to develop the main software projects: STM32 CubeMX version 6.15.0 and STM32 Cube IDE version 1.19. Those were the newest versions available when I started working on this project in summer 2025. The ST tools are not a free software like in free license, but they are available to use free of charge. Initially, I also developed a totally experimental MIDI sidechain software for Rasbperry Pi Pico in Arduino. It works based on the same principles as the STM32 options, and it uses the good old-fashioned MIDI with standard 5-pin DIN connectors. But that required quite a lot of custom hardware, so I abandoned that option. Anyway, I'll show you all the options later in this video. The gadget's operation principle is dead simple. It modulates the volume of a MIDI channel each time it is triggered by a selected MIDI note from another channel. Here is an example. I programmed a simple drum pattern on track number 1 of MC-707. Each time the kick drum hits, the Groovebox sends the MIDI note number 36 decimal over USB MIDI on channel 1. The MIDI Sidechain Gadget detects this note on this channel, then it immediately sends a series of control change or CC messages to modulate the volume of the tone track number 2, which in this case is the bass track. And it sounds like this. In general, the MIDI Sidechain Gadget can send the modulation messages to up to 4 MIDI channels. And for each channel, I can define a different CC message number. It doesn't even have to be the volume control CC number 7. It can be any single byte CC message in the range from 0 to 119 decimal. If I set CC message to value from the range of 80 to 83 decimal, the MIDI Sidechain Gadget can remotely turn the C1 to C4 knobs of the MC-101 or MC-707 Grooveboxes, so that I can record the modulation as motion. Then I can view or edit it in the motion editor. So basically, I've made kind of a hardware MIDI automation tool. The modulation is based on sending up to 16 values using a series of MIDI CC messages over a short period of time. It happens each time just after receiving a trigger node on the source channel. In the basic version, there are 4 different curves to choose from to modulate the sound. The curves are not editable from the user interface, but they can be edited in the source code. This requires recompiling the project and programming the device with such a modified firmware. The gadget can be controlled using its very minimalistic graphical user interface or with a serial terminal. Its main parameters and its active preset can also be changed by sending the control change or program change MIDI messages. This way, it can be directly controlled from the Groovebox if the track MIDI parameters are set correctly. I can modify 3 basic parameters of the sidechain effect. And if I send MIDI program change or PC messages, I can even change the preset of the sidechain gadget. This way, the preset change can be done automatically when selecting a particular clip. The user can choose one of the 16 presets and customize the preset's parameters. The presets work similarly to synth patches. It is possible to move between presets in various ways. It's worth keeping in mind that moving to a different preset discards any changes made in the currently edited preset unless it's saved. Those were the features. Now I think it's time for some bugs and limitations of this project. And some disclaimers. What can be more discouraging? Please don't consider the project presented here as a final product, but rather just a proof of concept. The software is not extensively tested and I have no idea with which instruments it can communicate. Here I'm just showing you how it works with the particular gear. if you feel inspired to build something similar, please be extremely careful about what you connect to your expensive gear and how you connect it. Remember, if you decide to implement the sidechain gadget concept, you do so at your own risk. And again, don't blame me if you break something. Another thing, the operation, especially the timing of the sidechain gadget, is not ideal. It cannot suppress the volume in, let's say, 0 time from the kick drum hit. It's because it relies on data handling and transmission between different hardware devices. In the MC Groove boxes, after recording the volume as motion, the delays can be corrected in the motion editor. Or the delays can be compensated with a small amount of non-zero attack time in the destination channel. Another, maybe less annoying limitation is that the sidechain gadget recognizes the connected devices only during its initialization, just after it reboots. So, after connecting a USB-MIDI device to it, the gadget needs to be restarted, preferably using its reset push button. It's probably a small bug, but I didn't have time to investigate it further. To connect and set up the sidechain gadget with the MC-707 Groovebox, I use a USB Micro B plug to USB-A socket adapter and a regular USB A to B cable that I would normally use to connect my MC to a computer. I connect the two cables together and to the Groovebox. And I connect the programmer side with the ancient USB Mini B cable to my computer, and I open the PuTTY terminal. I need to restart the gadget with its reset button to properly detect the device due to the bug that I told you about. The device will then be enumerated and the sidechain gadget will be reinitialized. The green LED will toggle each time the instrument sends its timing or presence information. It will happen if the device is configured to send out such information over USB. In the serial terminal window, we are able to see if the device has been at least correctly recognized. Each time the triggering node is played, the red LED is lit. The LED is switched off after the sidechain restores the full level of the volume. Then the modulation is finished until the next kick drum hit. Here I'm playing with some parameters using the control change messages sent from the MC-707. Here's how I record the sidechain effect as the motion pattern on MC-707. I set the destination channel to the MIDI channel in which I'd like to record the motion. And that's important. I set the CC value between 80 and 83 depending on which C1 to C4 knob I configured as volume. Here I use the virtual knob C4, so I set the CC number to 83 decimal. The motion record button is on. I start the sequence and I let it run for at least one full loop. After recording, I check the recorded motion with Shift plus Step and I push C4 to show the recorded volume motion. I can use the motion menu to view the recorded curve samples. I could optionally correct them or adjust them. It can be necessary if the sidechain gadget wasn't nicely synchronized and it reacted too late for the kick drum, and I would get some serious volume spikes. A kind of workaround to prevent the too late reaction to trigger nodes can be using a kind of ghost node. The sidechain gadget is not sensitive to the triggering node velocity. So here I put an inaudible kick hit just before the regular node that is expected to trigger the volume modulation. In case of the MC-101, everything works almost the same, except for the fact that the MIDI gadget cannot provide enough current to power up the MC-101. The USB driver in the gadget supports just a simple USB on-the-go host operation, and it doesn't support USB hubs. So a relatively safe and easy option here may be just to use batteries. Here everything works quite similarly. As an experiment, I connected this USB-MIDI interface. The USB interface has 4 MIDI DIN inputs and outputs. In my software, I ignore the cable index at the reception, and I notoriously set it to 0 for the transmission. So here I will be interacting with the MIDI interface number 1. I connect the USB-MIDI interface to the sidechain gadget with the USB cables. I connect my hacked power source to the MC-101, the audio cable. Now I connect the MIDI DIN interface in the standard way to have communication in both directions. And you can guess, it works too. Yes, you can see the activity LEDs blinking, and it works for all the 3 channels that are left on the MC-101. Here, as an experiment, I connected the base station to the USB-MIDI interface. I want the sidechain gadget to apply the sidechain effect to the synthesizer each time the kick drum note on message is sent from the MC-101. My base station is configured to communicate on MIDI channel number 6. So I navigate to the selected destination channel B and I set its value to 6. The CC message number is 7, so it's already correct. Now I'm just looking for a nice preset, preferably something sustained. This one's good. And I think I don't have to mention that it works too. I'm trying to adjust the depth, but I missed it the first time. Here we go. It gets heavier. The Nucleo board is less expensive and it will probably be available for a longer time than the very old Disk 1. So I thought it would be useful to port the sidechain effect to that board too. The STM32F439 and Cube IDE project is set up for this board, but I tried to run it also on the older one too. For the F29, it should be enough just not to use the on-chip cryptographic modules in the firmware. This time I interacted a bit more with the terminal, so that's why I brought the computer keyboard here. Now the Nucleo board is connected to the USB-MIDI interface. And I'm trying to change some parameters using the keyboard and the serial terminal on PuTTY. As you can see, it is possible, but rather inconvenient. And that was my main motivation to implement the control over the PC and CC messages. Here I added extra hardware modules like that to the Nucleo-144 board. And that's the simplified connection diagram. The display module is a very typical ILI 9341 and it's been available for years now. It uses the SPI interface and as you can see it displays the same graphics and text as in the Disk 1 version. The difference is that I had only the display without the touchscreen, but I added physical buttons to the board. The upper 2 buttons allow me to select a value to be modified and the lower 2 allow me to change the value. In this case I use the older F29 board and as you can see it works exactly like the new one without even modifying the software project. And yes, the project is the same, no matter if I decide to use the extra user interface components or not. My first attempt to implement the sidechain gadget was with the Rasbperry Pi Pico and a hardware which I adapted from my other project. It's based on the same principles as I presented here, but I programmed this one using the Arduino framework. I put this project on my GitHub too. The software also contains the information on how to connect the required peripherals to the Pico. I abandoned that project and moved on to STM32 implementation, but maybe it could be useful for somebody. Thanks for watching and see you maybe in the next video. Bye!